We're now going to begin populating our world map with citizens using the entity system. Let's create a new private method called createCitizens, and we will call this method after setup events in the init method. Now we'll initialize the list of citizens at the top of the createCitizens method. We're going to create a new info class called entityInfo, and we'll use it to store the total number of citizens for our entity system to create. We'll copy the mapInfo class and paste it into our new entityInfo script. Remember, these info classes are static classes with static members that can be accessed through their class name without an instance. This makes the information easily accessible throughout the simulation. We're going to define one static int called total citizens, and we'll set the value to 120. Now that we have our entityInfo class, we can return to the entity system and use this new variable while creating the citizens. First, we'll supply the total citizens count as the capacity for our list when initializing it. Then we'll create a for loop that counts up to the total number of citizens. Inside this loop, we'll initialize a new citizen object and then set some of its properties before storing it in our list. This is one of the only cases where I like to use the var keyword. When initializing an object using the new keyword, the class type will always be written on the right side of the equals operator, so it's pretty safe to automatically set the type with var. We are now going to create a few simple general utility functions that will help us randomly generate citizens around the map. Let's create a new script at the root of our scripts folder, simply called utils. Then open it in the editor. We will make this a static class just like our info classes. We are trying to write our simulation code in pure C# separate from the Unity rendering and input aspects of our application. So we're going to define an instance of the C# random class instead of using the Unity engine random class here. We now need to delete the Unity engine using statement because otherwise there will be a conflict regarding which namespace this random class is coming from. For now, we are also going to use a constant seed of 1 to ensure that while we test our application, we are always getting the same output from our random generator. Now that we have an instance of the random class available, we can use it to define a couple static methods that we can use to randomly generate content in our simulation. The first method will be a slight modification of the range method that is already available in the Unity engine random class. The Unity method randomRange uses an inclusive minimum but an exclusive maximum. There are advantages to using both approaches, but for many of our purposes, it will be much simpler to have an inclusive range at both ends. This means that if we ask for a random number between 4 and 16, we can get any number starting at 4 and going up to and including 16. The next method is a bit more involved. We want a method that will randomly pick a value from all of the values available in an enum type. To do this, we are going to write a method that has a generic template parameter called t. This will allow us to pass in an enum type, and our method will return a random value from that enum. We've already seen these generic template parameters in many of the Unity methods like getComponent. They are passed to the method using the pointy angular brackets after the method name. To begin the method, we will use a static method inside of the enum class called getTypes. This method will return an array of all the enum types for the type we pass to it. In order to get the type of our enum, we can use the typeOf function on our template parameter t. We now have an array with all of the enum values. To choose a random type from this array, we will simply use our random instance to pick an index in this array. Now that we have our random index, we can use the getValue method on our array to return the value at that position in the array. And finally, we will use the template parameter to cast this value into the appropriate enum type. Then we'll return this enum value from the method. That completes the two utility methods we need in order to generate our citizens. Let's return to the entity system class and make use of them. The first thing we can do is pick a random direction for our citizen using our random enum value method. Seeing this should help clarify how this method works. Next, we can use the exact same method to choose a random nation for this citizen. Now, we need to define another method to help us get a random position for the citizen. But this isn't quite as simple as picking a position on our map, because it's possible that the position could be set to solid. In that case, we shouldn't be able to place the citizen in that position. So let's go to our map system and define a method that will find an open position on the map for us. We'll set up a public method called getOpenPosition. It will return an int2 vector representing a position that is not solid. But in order to do this, we also need to define another method that simply tells us whether a position on the map is solid. We will name this method isSolid, and it will return a Boolean value. Our first version of this method will take the usual x and y components as input. We will first check to make sure the position is on the map. If it is not on the map, then we will simply return true. This will ensure that all positions off the map are considered solid for collision purposes. If the position is on the map, then we'll use getCell to get the cell at that position, and then return the solid property of that cell. We will also keep to our standard practice of defining an overload for this method that takes an int2 vector for the position and then calls the component version. Now that we have these two methods, we can use them to complete the getOpenPosition method at the bottom of the class. We will first define a new int2 vector that will represent the position we're looking for. We are going to use a do-while loop, which is a version of the while loop that checks its condition after each iteration instead of checking it before. Inside the loop, we'll use our randomRange method to find a random position within the bounds of our map. Then we will use the while condition to check if this position is not solid. As soon as we find a position that is not solid, we will break out of the loop, and then we can return this vector. It's possible for us to end up in an infinite loop here if there are no open positions on the map, but for now we're going to consider that an error in map making and not an error in the code. If you've created a map with no open positions on it, then things have already gone wrong for your simulation. But it would be a good idea to handle this case eventually with some kind of timeout where we provide a null position. Now we can return to the Entity System class and finish creating our citizens. Let's grab the instance of the map system from the Simulation Manager singleton instance, and then we can access the getOpenPosition method in order to find our citizen a clear space on the map. The last thing we need to do is add this new citizen to our list of citizens so that the entity system can keep track of them. That's all we need to do in order to create a series of citizens for our simulation. In the next video, we're going to introduce a createCitizen event that we can fire to let the world render component know that there is a new citizen which needs to be rendered to the screen.